Okay, YouTube, let's continue building a new programming language. I think in the last episode we were right about here somewhere, and let's also implement this toString function. So that we have it. Probably should return a string. And then we say the token type also needs to be stringable. And to make it token type printable, we can just do this, implement format display for token type, should work. And then we can say format like this. Let's try that. We run a check. Oh, oops. Yeah, so no semicolon. And literal value doesn't implement. Let us just debug formatted for now. Okay, now it looks like it's just error warnings. Good. Let's keep it like that. Okay. Then now we have this token type. Now the idea is that we get a program. The program will look like this. Something like this. But this is just a string of characters. So the job of this scanner type that we're defining up here is to go through the string of characters and figure out that the first three ones is a variable, tokens, the keyword, var. The next one is an identifier, and then we're assigning. So what he's saying here is that the job of this scanner, lexical analyzer, is to take the characters and eat them. So that once we have identified the first three as a var token, a var keyword, then we don't use those again. So we consume them. Once they are consumed, we spit out the token corresponding to whatever it was. And now he also says that you can actually use regex to do this. But the using regex kind of hides the inner mechanics, so we won't be doing that. Instead, we'll kind of implement everything ourselves. So let's return up to the scanner and start to give it some fields. So we want the source, and I'm gonna do a string reference. Here it's a final string. I guess that means, I don't really know Java that much, but I guess it means that it can never change, or probably never be. Oh, okay, who knows? And then we want some tokens, which should be a vector of tokens. the token type we have down here, and that is it. We already have our new function, but now we just have to fill it in. Just make an empty vector. Oh, okay. Doesn't like that, so let's do a string, and then we choose string this. And now we just get warnings. Good. Okay. Store the source code as a string, and we have a vector of tokens ready to fill. And then we want to implement the scan tokens loop. And the idea is that as long as there are tokens left to consume, and now we need a is at end function. This is getting a to do. Then there's like some magical variables coming here. Start, current. Okay, they are defined down here. So let's add those. And we can do a u unsigned integer because it don't really make sense to have negative and line number. And when we initialize, we put them to 0 and 1. Okay. And that means we need a mutable reference since we're changing things. And then we want to scan one token. And I guess the final thing the function does is to add a new token with an end of file. And let me just remember how we did this. So an empty string, no literal, and the current line. And then we have to add these things. Perfect. And the return value of the function is the tokens. And we wrap it in an OK. So we also have this failure condition that can happen, and we will say that that probably happens in here, so we can do this automatic unwrapping. And we need to implement this scan token function. It should be a token unless it fails. All right, let's see what's next in the book. So yeah, the start and current fields are offset into the string. The start field is the first character of the current thing that we're scanning, and current is the character that's currently being considered. So for example, if we were doing var test equals this, then in the beginning, start would be 0, and then we would gradually scan this token. So current would start at 0 and then go to 1, go to 2, and then it would go to 3 and see the token is done. And then it would, because there's an empty space, and then it would realize it's a keyword and emit a token, and then it would increment start to, or I guess it would just increment current to go to here until it finds the next one, the next non-empty empty character, and then up here, we then would assign start to this one. Not really sure why we need start yet, but let's keep an open mind. So this one we want to say current is self.source.length. Just check it real quick. There is an error because the end of file, because we didn't say use token type. String is not a type. What? Okay. And this should be self.line. And we don't need these extra parentheses. And it's not called add, it's called push. And there's nothing called lexen, it's lexene. And you know what, why not use u size. There's a problem down here. Size. Okay, so not sure what to do here. Let's clone it. And it's not gonna like that because token is not clonable yet. And token type is not clonable. And by the way, it should be okay to clone this because it's just a few very lightweight types. And literal value is not clonable. And now there's a problem in main. We need a mutable thing. we're back to all our warnings, I think. Okay, so we have this at end. So recognizing lexemes. So at each turn of the loop, we scan a single token. This is the real heart of the scanner. We start simple. Imagine if every lexeme were only a single character long. All you would need to do is consume the next character and pick a token type for it. Several lexemes are only a single character in log, so we'll start with those. Now, again, there's this undefined function, but we will just say this. Then we can match C with, not that, but fuck. Yes. And this is how you could do it. Just say character to and then add the corresponding thing. We can also just do a quick macro here that does the following. It will take the char thing, it will take the token thing, which probably should be an identifier, and then it will do this. Will this work? Let's do a check. Unexpected. Let's remove the comma from up there. Interesting. If we add a little space. Now it still thinks it should be part of this thing. Okay, cannot really get that to work, so instead we'll just do this. Let's check it. Okay, should be star, and check it again. That one we don't need, didn't work. Advance is not defined. It is now. Now it is, and then there's some add token. Which should take a token type. And not all patterns are covered, so for now we will add an error, unrecognized char. Let's do format. And now there's just some warnings. Wondering why slash is not here? Don't worry, we'll get to it. So now we go to the helper functions. So we want to say the character we want is the source at the current index, and probably it should clone it automatically or copy it. And then we want to say we increment current, then we return the character. String cannot be indexed by usize. So one thing we can do is say, give me the bytes, and if every character is one byte, so it's ASCII, then it should be fine. And then let's convert it to a character. Unused variable token type, good. So okay, he just has two functions. Whatever. So we can, do we have overloads? I'm not sure. And he's doing a null, so we're gonna do a none. Yeah. And now we can say, what is the text of this token? It is the substring, and then we do this. Can you do this? And clone. Format, let's check it. And that did not work because there's no overloads. So since there's no overloads, let's call this one add token lit for now. Let's check that, if it compiles. There is no clone, so let's say we want this to be a string, right? Lexim is a string, yes. So let's just put that here. Maybe we can collect this. Okay, It's a little bit annoying. So let's do it that stupid way for now. So the question is whether we should include the current. For now we assume we don't. And then I want to push the, maybe we shouldn't call bytes all the time. Let's make this one. So bytes at I as a character. Do we push that? And we are back to all the nice warnings. So that should work. Should we make a test? Nah, who needs testing? So advanced method, it gets the current character, increases current by 1, and add token, clearly adds a token. Before we get too far in, let's take a moment to think about errors at the lexical level. What happens if a user throws a source file containing some characters that this language doesn't use? Right now those characters get discarded. Well, not really, not in Rust. They aren't used. It doesn't mean the interpreter can pretend they aren't there. Instead we report an error. Exactly. So we kind of have this built in from the very beginning. So note that erroneous characters still consumed by the earlier call to advance, sure. That's important so we don't get stuck in an infinite loop. I don't know, what is this error function then? I guess it's this one, it just like prints something out, but we completely break, which I think is fine. I don't know why he doesn't. Okay, he says we also keep scanning. That is kind of a good point. And actually here the error message for this should be something like at line, and then we do self.line. So actually here we want to not just break out right away, we want to accumulate the errors. So maybe we do this, and then we say match this guy with an OK token. Why? Actually, it's not returning a token the way it looks right now. It's just doing nothing. So an OK, we don't do anything. But if there is an error with some message, then we push the message into here. And finally, in the end, we say if the length of the errors is greater than 0, then we want to return an error where we join all the errors together. And to join them together, I think we can do something like this. And then we want to map over the messages, and we want to say join push string message. And actually, once we have pushed the message, we want to push a new line. And that should be it. So we map that, and then we return joined. Does it work? It does not work because I forgot that. And then we have to say, give me the iterator of the vector. And should be mutable. Great. So basically we scan all the tokens, and every time we see an error, we push it to this error list. And if there are any errors at the end, then we return the error messages for those. I'm not sure it will work very well, but this is at least a start. So I think we will wait until the next time to look at operators. Until next time.